Hi, my name is Tahsin Nabi, representing Team 32. Our project is called Scene Scope. We were addressing a critical gap in autonomous driving. While data is abundant, finding difficult scenes worth training on currently requires a lot of manual inspection and interpretation, or waiting for models to fail after training. This matters a lot because researchers and regulators like the NHTSA or other researchers like Argoverse at Georgia Tech need a scalable way to prioritize complex scenarios to ensure public safety and interpretable models. What makes SceneScope novel is its multimodal approach. Instead of looking at aggregate benchmarks, we allows users to combine and compare different architectures like camera-based or LiDAR-based or radar-based models side by side, as well as we enable filtering and visualization of a model performance in addition to quantitative metrics that other attempts don't offer. We also created a multimodal difficulty score, which is calculated as a weighted sum of intrinsic traits, object density, vulnerable road users, etc. In terms of our backend and front end, we used GCP to host a pipeline hosting all of our static images, and then we have a front end built in Vite and React to bring together all of our analytics and visuals. So here you can see a little bit of our Vite web app. You can see us, what we're doing here is we're looking through a couple of different camera angles as well as what the model output actually looks like. So you can see bounding boxes around different objects, and you can see that for all of the different rotated images, like the back of the car, the front of the car, the left of the car, they all correspond to the exact same time step and in the exact same place, like locally. So what we can actually do from here is we can actually step through each scene, and we can look at different angles, and we can see all the different bounding boxes with different types of objects highlighted in the scene. And then corresponding to those bounding boxes, as well as the model colors themselves, we can actually look through the different objects as well as a histogram of all the objects in that scene. So it allows us to visualize that. And this actually pairs also with our difficulty score here based on each model. We can also filter based on the objects themselves such that we change what the actual image output is, as well as search for specific types of scenes later. We evaluated scene scope across 2 different models and over 20 different scenes, looking at hundreds of gigabytes of scene data that came in the form of images, LiDAR, and radar frames. We benchmarked our scores against IOU, calculated difficulty metrics, and then evaluated our results. Our results showed that Model 3 generally performed better than Model 2, and our qualitative comparison of alternatives showed that our project gave a lot more to the table and was an overall success. In conclusion, SceneScope provides a scalable roadmap for safety by bridging the gap between raw data and interpretable insights. In the future, we plan to scale to the full new scenes dataset, integrate automated explanations for ranking, and as well as develop more robust features. Thank you for your time.